what?
Slope.
Find the slope. So pick any 2 points and find the slope. So let's say maybe these 2 points. So if you want to find the slope between those 2 points, it's going to be what minus what on top?
7 minus 3.
Over?
1 minus 0.
So the slope is going to be 4 over 1. So the slope is what?
4.
4. That's nice. So what point do you want to use for your point slope form? You can, and I want to go back to always use point slope form always, even if it's going to be slightly harder because you're not always going to have an intercept. You could use the intercept in this case. That's totally fine. So if you use the intercept in this case, what would it be? Y minus
3.
Y minus 3 is equal to the slope times x minus 0. The reason I want you to do this is I want you to get into the habit of being okay stopping here. It's totally okay to stop here. If the only time you need to write something in slope-intercept form, there's 2 reasons. One, I actually ask you, write it in slope-intercept form, or there's some other reason why it's useful. There's some other reason. Are you always going to have the intercept? No, you're not always going to have the intercept. I'd much rather you default to this. This is going to be more useful on the balance of things. So you end up with this. So yes, you could write it as y is equal to, if you wanted to, 4x plus 3. It's the same thing, absolutely. Why is it really helpful to have that function? Why is it really helpful to have that function? Yeah, so now we know f prime of x is equal to 4x plus 3. So if I ask you, what's the derivative when x is 12? What's the derivative when x is equal to 12? What's the derivative when x is equal to 12? Yeah, f prime of 12 is going to be equal to 4 times 12 plus 3, which is 51. This allows us to pretty much instantaneously find the derivative anywhere, and allows us to skip over finding the using the limit definition on every single point. Okay, so let's try this right here. Let's try this. It said f of 1 is equal to what? 5. And if you're interpreting your answer, that is says that after 1 second, the person is 5 feet from home. It's not necessarily the distance traveled. In this case, it is the distance traveled. But here's the thing. If he turns around for any part of that, the distance traveled is not going to be his distance from home. What did f prime of t come out to be when he did all the algebra out?
F prime t equals
Negative 2t plus. If you do this out, you keep t in there. And the reason you do this first is then, after you do all that work, when you ask for f prime of 1, well, you know that f prime of t is equal to negative 2t plus 6. What can you just plug in? Oh, plug in 1. What do you get? Plug in 1. What do you get? 4. And what does that mean? The person is moving at
4 feet per second.
At 4 feet per second away from home at
1 second.
After 1 second. Because this person's speed is changed. So, okay, keep going here. What about f prime of 5? What did that get? It's negative what?
4.
Negative 4, right? So at f prime of 5, what's going on here? The person is what? What's going on now?
Moving 4 feet per second backwards.
Yeah, the person is moving 4 feet per second towards home. Is that important? Yes, towards home. So when you find when you do the derivative function first by doing, what were you doing this time? The limit as h goes to 0 of f of t plus h minus f of t all over h. All the h's end up canceling out from the denominator, leaving you, after you plug in 0, with negative 2t plus 6. That gives you the derivative function. What we did before was plot points and then come up with a pretty good estimate, which turned out to go through all those points perfectly. But in this case, you can use the limit definition to get the actual derivative function right there. You can get the actual derivative function right here, which is super, super